The usual experimental setup in the school laboratory to determine the speed of sound V in air is shown in the figure. The setup includes a gas tube open at both ends, a tall glass jar filled with water, and a set of tuning forks. The resonance method is adopted to determine the speed of sound in air. Part A. What is the other measuring instrument needed to perform this experiment? They have not given meter ruler. It is compulsory to use the meter ruler for the experiment. Therefore, we have to write meter ruler. Then part B. Fill in the blank with the appropriate words in the following incomplete statement. The statement is not given in the PDF, but the original paper, they were given and a statement like this. When an object vibrating, at the now there is a blank space, frequency of another object. The first object makes the second object resonates. You have to fill the blank. Then we know that for resonate means when an object is vibrating, another object is automatically vibrating. For resonate, both objects should have same frequency, and we know that it is equal to the natural frequency of resonance object. Then we have to write natural frequency for the blank space. Natural. Then part C1. What is the type of wave produced inside the tube resonance? Underline the correct answer. C part 1. Longitudinal transfer. We know that for a resonance tube, we are using sound waves. Sound waves are longitude waves. Therefore, we have to write longitudinal waves. We have to underline this one. And second part, we have to select waveform progressive or stationary. For tube resonance, wire resonance, rod resonance, we are using stationary waves. Therefore, we have to underline stationary. The waveform is not progressive. It means not moving continuously. It is only a wave pattern formed in the resonance tube. In part 2, how is the wave that you have selected in part C1 above produced? You have to write the method, part C, Roman number 2. We know that there are two waves in the resonance tube. First one is incident wave, second one is reflected wave, and they are by superposition. It makes a corresponding stationary wave. Then we can write superposition of incident and reflected waves. Part D. State the experimental procedure in stepwise that you would adopt in order to obtain the resonance length corresponding to the first mode of vibration. It means fundamental, they have given it in the bracket, of the tube accurately. You have to write the steps. First one is immerse the tube completely with the in the water jar, in the water. Then second one, keep the vibrating tuning fork above the top of the open end of tube. Third step, raise the tube out from the water such that the length of air column is increasing until a loud maximum sound is heard. There are four main steps. First one, immerse gas tube fully in water. Keep the vibrating tuning fork near the open end of the tube. Third step is raise the tube out of the water to increase the length of air column. Last one, fourth one, measure the length when a loud maximum sound is heard. Part E, you have measured the resonance length corresponding to the first mode of vibration and second mode of vibration of the given tuning fork of frequency F. Part 1, if the resonance length corresponding to the first mode of vibration is L1, write down an expression for the L1 in terms of wavelength lambda and lambda of the wave and the incorrection E of the tube. We have to consider the incorrection. Then first mode means it is fundamental. I will draw the wave pattern for fundamental frequency. We know that it is acting as a closed tube because of this part, this end is touching with water. Therefore, it is a closed end. We have to draw a knot for the closed end, and this is an open end. We have to draw antinode at the open end. Therefore, this is the basic wave pattern in the tube. And we know that length of the tube is L1 for this situation. We are increasing length by using water level, but for the resonance, we can get resonance length is L1. And we have to consider incorrection. Incorrection is E. Incorrection means the distance of wave, the length of wave out of the gas tube. Now we can consider wavelength. We know that there is a half of loop. It is 1/4 of wavelength. We know that this is a full wavelength. Therefore, there are two loops for a full wavelength. Now there is only 1/2 of a loop It means 1/4 of wavelength. Now we can write an expression. Lambda divided by 4 should be equals to L1 plus C. It is the relationship, but we have to subject L1. I will subject L1 by using this equation, lambda over 4 minus C. It is the answer for part 1. Then part 2, if the resonance length corresponding to the second mode of vibration is L2, write down an expression for L2 in terms of wavelength of the wavelength, lambda of the wave and n correction E of the tube. We have to remember that this n correction is depending only on diameter of tube. When increasing diameter, we have to consider that n correction also increases. Then for the second part, we have to consider next overtone. It means first overtone. This is fundamental, or we can consider it as first harmony. And now we have to draw first overtone, or it is second harmony. This is the wave pattern. Now there is a full loop and there is another half of loop. Length of the tube, n correction. You have to consider n correction only for open end of the tube. Now there are 3 half of loops. Therefore we can consider lambda divided by 4 into 3. Now we can construct the relationship. Lambda over 4 times 3 should be equals to L plus C. Again, now resonance length is L2. We have to subject L2. Then L2 is 3 lambda over 4 minus C. Then part 3, hence write down an expression for L2 minus L1 in terms of lambda. L2 minus L1. We have to subtract this equation and this equation. Part 3. L2 minus L1 equals 3 lambda over 4 minus E minus lambda over 4 minus E. Now I will simplify it. L2 minus L1 equals 3 lambda over 4 minus E minus lambda over 4 minus into minus plus C. In correction is cancelling. Then L2 minus L1 equals 2 lambda over 4. It means lambda divided by 2. Part 4. What is the advantage of obtain L2 minus L1? We can calculate wavelength by wavelength without considering n correction. Then we have to write for part 4. We can calculate lambda without using n correction. Substitute V and F in the expression written in E part 3 above and rearrange it to obtain a straight line graph. We have to substitute V and F, and we have to rearrange the expression to rearrange the equation to draw the graph. Now in next part they have given the corresponding graph. We can see the graph. Then we can obtain the corresponding physical quantities we have to consider for x and y axis. We can see they have drawn L2 minus L1 as the y axis. It means dependent variable, 1 over f as the x-axis, it is independent variable. Now I will use common equation for any type of wave. V equals S lambda. It is the common equation for all waves in the world. Now we can substitute lambda. We know that lambda over 2 is L2 minus L1. We can subject lambda by using this equation. It is 2 times L2 minus L1. Then checking the graph, we can see they have drawn this part as the y-axis. Or we can decide directly. We have changed corresponding frequency. In the question they have given, there is a set of tuning forks. Therefore, we can change frequency of the resonance tube by using a different frequency, tuning fork with a different frequency. And this is the measured value. We have to get measurement we are getting by using the experiment for the y-axis. Therefore, we have to subject L2 minus L1. I will subject L2 minus L1 equals to V divided by 2S. Now S is the independent variable. Therefore, I will get it as V over 2 times 1 over S. It is the type y equals mx. Y equals mx. Now part F. The graph of L2 minus L1 against F1 over S is shown in the grid below. Calculate the value of speed of sound in air, V in terms of using the graph. V in meters per second using the graph. Now, we have to check the equation. When checking the equation, we can see that gradient is V over 2. Therefore, we have to find gradient by using the graph. Then, to calculate gradient, we have to consider 2 points of the graph. There are 3 conditions we have to consider when getting points by using the graph. First one is both points should be readable. It means we can read y and x values easily. Second one is we have to get 2 points within the range of readings. I will explain it like this. If there are points in the graph like this, we have to draw the suitable straight line. And we have to get 2 points between this one and this one. And third one is we have to get 2 points with a maximum separation. There is a maximum separation, but between this point and this point, and there are x and y values we can read directly without using any calculation. It means we can count x and y values by using small squares in the graph paper. Then we have to select two corresponding points. I will show the graph in the marking scheme. They have marked 2 points like this one and this one. Now you can see there is a maximum separation, and 2 points are between the range of reading, and we can read clearly x and y values by using small square. For the first point, I mean lower point, this one, x value and y value. X value is 1.5, 1.6, 7, 8, 9, 2, 1.9. X value is 1.9, but you can see the axis. It is see the physical quantity in the x-axis. It is 1 over f multiplied by 10 to the power minus 3. Then we have to consider first point is x value 1.9 into 10 to the power minus 3, and we have to consider y value corresponding to the point 32 centimeters. Therefore, we have to use 10 to the power minus 2. We have to multiply by 10 to the power minus 2 to get the y value in SI unit. And for the upper point marked in the marking scheme, x value is 3.9 into 10 to the power minus 3. We have marking scheme by using arrows. Y value is 65 centimeters. Therefore, we have to use 10 to the power minus 2. Right. Now we can use these two readings, 2 points, to calculate gradient. We know that gradient of the graph should be equal to V over 2. I will write the gradient. Part F. Gradient equals difference of y divided by difference of x. It should be equals to V over 2. Now, difference of y, I will subtract this point and this one. 65 minus 32 into 10 to the power minus 2. We have to consider in meters. Then we can subtract x values. 3.9 minus 1.9 into 10 to the power minus 3. Now, we can simplify it and we can get the v value. 10 to the power minus 1, we can get it to the numerator as 10. 5 minus 2, 3. 6 minus 3, 3. Divide by 9 minus 9, 0. 3 minus 1, 2. Multiply by 2 equals 3. I have bring these two values for the left hand side as a multiplication. Then we can cancel out 2 and 2. 330 meters per second. Then part G. Instead of instrument mentioned in part A above, suggest an alternate way to determine the resonance length more accurately. Part A, we have written meter ruler. Now they have asked by using alternate method. We have to get resonance length. It means we can't use meter ruler. We can use a scale attached to the resonance tube. Then answer for part G by using a scale attached to the resonance tube. In part H, what is the essential parameter that must be given when when expressing the speed of sound in air. We know that speed of sound is depending with room temperature. Therefore, it is compulsory to give the corresponding room temperature. Then we can write room temperature.